We've done a lot of conceptual work up to this point. Now we're going to get into applying some algebra to these examples. So not only do we have to solve for x, but in order to do that, we've got to decide what type of angles am I dealing with to help me write my equation. So first thing, number one, this top left example, the only thing these two lines or angles share is this vertex. They are a pair of opposite angles that only share that vertex, which makes them vertical angles. Remember, vertical and vertex. That's what we're going to use. That's the only thing they have in common. So I'm going to use that to kind of help me guide myself. And once I realize they only share a vertex, so that makes them vertical angles, we've got to remember vertical angles are congruent to each other, which is going to help us big time because now we can write our equation x plus 16 has to equal 4x minus 5. Now that I have this, I can solve this down because I can get my x's on the same side. So as I'm going through this, remember, the first thing I want to do is get my x's on the same side. I do that by moving my smallest x value, my number farthest to the left on the number line. So that would be 1. So I'm going to subtract 1x from 4x on both sides. That way I can only deal with x on one side of the equation. And we will do this in separate steps. If you wanted to combine this, the step we're taking right now and this next step we're about to take, you absolutely can. Because now that I have my x's on one side all together, I need to isolate that x. So I can't do anything about the multiplication, but I can get rid of that subtraction. The way I do that is I use the inverse operation. So the inverse of subtraction is addition. So I'm going to add 5 to both sides. 16 plus 5, if you need it, is 21. And now the inverse operation I need to use here to get rid of multiplication is division. And I know, of course, 21 divided by 3 is 7. So my missing variable has been solved for. X equals 7. Let's go on ahead and do this top right example. Okay. Remember, these two angles are a pair of angles that form a straight line. So if it's a pair of angles that form a line, we have a linear pair. And remember, linear pair is going to be supplementary, which means they're going to add to 180. So I have 4x plus 20 plus x minus 10 equals 180. What I want to do here is I want to combine my like terms. So I've got 4x and a positive x. I've got a positive 20 and a negative 10. So 4x plus x is going to be 5x. 20 minus 10 is going to be, that's a positive 20 and a negative 10. So that is going to end up being positive 10 because 20 minus 10 is 10. Those are going to equal 180. Now I want to isolate x as best I can, start to work that way. So I do the inverse operation of addition. So I subtract 10 from both sides. I get 5x equals 170. Now I need to get rid of multiplication. So I use the inverse operation, which is division. 170 divided by 5 equals 34. Over here on the bottom left, we've got a little bit more stuff going on. The first thing I'm going to do is I'm going to use my vertical angles to solve for y. So I know that y plus 23 has to equal 63 because these are vertical angles. So these are going to be congruent. I'll go on ahead and go on the inside of that. These two angles are congruent, so I can set them equal to each other. Y plus 23, I want to get y by itself, so I subtract 23 because subtraction is the inverse of addition. Y plus 23 means I need to subtract 23. 63 minus 23 equals 40. So I can plug that in for this y. So 40 plus 23 equals, 40 plus 23 equals 63. I know this whole thing has to equal 63, and I can actually use that again because 2x minus 17 plus 63 have to be supplementary because they are a linear pair. Okay, so now I can use that same information to help me out. I'm going to go on ahead and combine like terms first. So 63 minus 17 is 46. It's a positive 46. Just so that you can see that, if I had plugged in negative 17 plus 63 into my calculator, I would have also gotten 46. So it really didn't matter which way you chose to go about doing this. 2x plus 46, I want to isolate my x as best I can, so I'm going to get rid of addition by using inverse operation. So I'm going to subtract 46 from both sides. 2x equals 180 minus 46, 134. Divide both sides by 2. X is going to equal 67. So that takes care of my x and my y. Over here on the right-hand side, we've got a lot going on. So first thing, I want to get my x's figured out because I want to keep my common variable. I can't really add x and add y, but I can solve for x right away because 3x plus 5 or 2x plus 5 and 3x minus 33 are vertical angles. So I can set them equal to each other. 2x plus 5 equals 3x minus 33. And I'm going to go on ahead and combine some steps. So I'm going to subtract 2x from both sides. And if I know I'm subtracting 2x from the left, I want to add 33 from my right. 33 plus 5 is 38. Equals 3 minus 2 is just going to be x. So I know x equals 38. I can go on ahead and plug that in. So 2 times 38 or 3 times 38, these should both be the same thing. 2 times 38 plus 5 equals 81. 3 parentheses 38, close parentheses, minus 33 equals 81. So either way I go about doing this, 81 degrees. So now my linear pair of 81 degrees plus 4y minus 1 will equal 180 because I have a straight line formed by 81 and 4y minus 1. I can do it with the other 81. It really doesn't matter. Okay, so I'm going to combine like terms here first. 81 minus 1, so I've got 4y plus 80 equals 180. Work to get y by itself by subtracting 80 from both sides, because if I do it to one side, I do it to the other. 4y equals 100. To get y by itself, I need to divide both sides by 4. Y equals 25. There we go.